Hi there, this is Professor Eckhouse, and I'm going to talk about solving quadratics by factoring. First, we're going to look at how to solve any polynomial, including a quadratic, by just using a graph, and then we're going to look at it through factoring methods. So first, try to answer these two questions. Okay, so hopefully you had a chance to think about those questions. And what is the difference between an expression and an equation? So an expression has no equal sign, and an equation has two sides equal to each other. So an expression is just one side of the equal sign, really, if you think about it that way. But the equation has two sides, and there's an equal sign in between them. So two things set equal to each other. So what does it mean to find the solution to an equation? So what it means is that there's an xy pair that makes the equation true. So given f of x equals some number, in other words, we have y. So we're always given the y, so there's an equation and it's equal to some number. So that is the y value. So we are finding the input. The input is x. We're trying to find that input. So that is finding the solution to an equation, finding the input of an equation that makes the given y value true. All right, so we're going to look at finding the solution to a polynomial just using a graph. So if we have f of x equals this equation here, what would it mean to set that equal to 0? So when we have f of x, equals 0, that means that f of x is y. So that means y equals 0. So where is y on a graph? Y is the vertical axis, right? X is the horizontal axis. So what does that mean? Well, it means in this case that we would have like x cubed plus 2x squared minus x minus 2 equal to 0. So that means we have set the equation equal to 0, and that is our y value. So we're looking for x. That's what we're trying to do when we find the solution. What is x when y equals 0? So how could we do that using a graph? So think about, where is y equal to 0 on the graph? Well, y is equal to 0 on the x-axis. The x-axis is where it equals 0. So how could we use the graph to find x cubed plus 2x squared minus x minus 2, which is this purple equation right here, this purple graph? So that is going to be where it crosses the x-axis. So it crosses the x-axis at 3 different points. So those are going to be the x values that we would plug in to get 0. Okay, so where x equals -2, where it equals -1, and where it equals 1. So those are those 3 points right there. So at x equals -2, -1, and 0, those are considered the solutions to this equation when it is set equal to 0. Okay, so in general, solutions are where the graph equals, the y value equals 0, the x-axis. Also called roots, those are also factors, but right now we're going to call them solutions. All right, so let's look at another problem. So let's start by doing this graphically. So solve x squared minus x equals 0. So this is the graph of y equals x squared minus x. So since we're saying to solve it when it equals 0, what we're saying is solve it when it crosses the x-axis. So where are the places that it crosses the x-axis? And that is here and here. So the solutions to this equation is x equals 0 and x equals 1. So what, again, does it mean that an equation equals 0? What does that mean? So that is when y equals 0, what is x, right? What is x? That's what we're doing. What is x? So when y equals 0 is when an equation equals 0. It is when it's the places where it crosses the x-axis. Okay? So how could you figure this out? How could you find x without a graph? Well, Well, in this case, we've got x squared minus x equals 0. So let's work backwards a little bit. So what we're saying is when x equals 0, we get 0, and that is true. 0 minus 0 is 0. And we also have when x equals 1, we get 0. And yes, 1 minus 1 equals 0. So both of those check, and they are solutions. So how could we do that? Well, we can do it by saying, well, whatever number I could find where x, I plug in x and I work it out and I get 0, that is going to be my solution without a graph. So how could we do that? And we're going to use the principle of zero products. If you multiply two numbers and get 0, what can you say about the two numbers? This is why we're so caught up in factors in algebra, right? We want to find the factors because if you take any number, anything, right? Anything times 0, you get 0. Right? So either one of the factors could be 0 and you would get 0. So 0 times any number, again, equals 0. It doesn't matter what order. So as long as you've got factors, and that is the key, factors, two things multiplied together, not added, multiplied. Okay? So the principle of zero product states that the product, if the product of two numbers is 0, at least one of them is a 0. So either A is 0 or B is 0 when you have two things multiplied together, or both. And so we're going to assume both in this class. All right. So using factoring methods to find the solutions to a quadratic equation. So take a look at this, pause the video, look at this given equation right here that's already factored for us. And then if we worked it out and we got x squared plus, I'm going to FOIL it, outside is 3x, inside is 2x, and last is 6, we get this equation. So then I graphed it. Okay, so it's graphed. So where do you think the solutions are, and how does that relate to these two factors I've got highlighted? X plus 2 times x plus 3. And remember, those are factors. I've got two different things here. I've got x plus 2 times x plus 3 with multiplication in between, factors. So we've got a -3 and a -2. So when x plus 2 equals 0, or when x plus 3 equals 0, we get an answer. All right, so what is that answer? That is the place where it crosses the x-axis. So if I solve this, and I don't really even need these parentheses, right? I'm going to take those away and just say, well, when the thing inside the parentheses, x plus 2 equals 0, that means that x must be -2. And then the next one, x must be -3 to make that equal 0. Well, there's our -2 and our -3, our solutions. All right, so let's try that applied to a new problem. All right, so now we're given this problem without it being factored, so we'll have to factor it. Okay, so we've got x squared minus 11x plus 10, and it equals 0. So let's factor this. So we're going to have x and x, and what two things can I multiply to be 10 and add to be -11? Well, it's going to have to be a negative and a negative to get 10, and if we just have 10 and 1, I would get -11. All right, so I get those equal 0, so we're going to have to take them separately. X minus 10 equals 0, and x minus 1 equals 0. So that means x equals 10, or x equals 1. Now let's take a look at our graph. What do you see over there? We've got it crossing at 1 and 10, which is what we found here and here. Okay, so this is how we solve quadratics. All right, so let's take a look at this one. You might want to pause the video and give this one a try. All right, so first off, you may not notice if x squared minus 4x equals 5, then we need to rearrange this to say x squared minus 4x minus 5 equals 0. What did I do? So I subtracted 5 from both sides to get 0 on the right side. Okay, so now we've got this equation is right here, and that is graphed right here. All right, so I get x squared minus 4x minus 5 equals 0. So I'm going to have to factor it, and I get x plus or minus something on both of them. Now I have to find something that multiplies to be negative and adds to be negative. So I'm going to have a plus and a minus. Multiplies to be negative means I need a plus and a minus. So I find that I get x minus 5 and x plus 1. So let's double check everything, especially the middle term. So minus 5x plus 1x gives me negative 4x. So always check, at least in your head, to make sure you unfoiled properly. In other words, you factored. All right, so we've got x plus 1 is going to equal 0, because remember, this one could equal 0, or this one could equal 0. So we check them both, and we get x minus 5 equals 0. So subtract 1 from both sides, and I get x equals negative 1. Add 5 to both sides, and I get x equals 5. So now check the graph. Here's the graph of the equation. I've got x minus 1, or x equals minus 1 right there, and x equals 5 right there. So those are my two solutions to this equation. All right, let's try another one. So we're going to solve it first, and then we're going to make a rough sketch. And it's really hard to make a sketch if you don't know the vertex. We've talked about finding the vertex very briefly a few modules ago, so we're going to do it again. So first, just try to factor that. Pause the video and give it a try. Okay, so when I factor this, I get x plus 1 and x minus 3 equals 0. So double check, make sure the middle term works out and the last term works out. The first one's easy because it's just x times x. All right, so we get x plus 1 equals 0 and x minus 3 equals 0. That means x equals negative 1 or x equals 3. So we've got two places that this crosses the x-axis, and that is going to be at negative 1 and 1, 2, and at 3 right there. Now, does this thing face up or down? So there's not a negative right there, and that means this thing does that. So it's going to look like that, but where's the vertex? So let's look at the equation for the vertex. The vertex is at hk, where h is negative b over 2a. Okay, so we need to figure out what a, b, and c are from our equation. A is the number in front of the x squared, that's 1. B is the number in front of the x, that's negative 2. We don't really need c, but just to be thorough, I'll say c is negative 3. So that came directly from the equation right there. All right, so we've got negative, b is negative 2, and then over 2 times 1. So we've got negative 2 over 1 is going to just give us 1. Well, that's easy. All right, so now to find k, we have to plug 1, what we just found, into the equation. So I'll say 1 squared minus 2 times 1 minus 3 equals what? So we're finding f of 1. All right, so we've got 1 minus 2 minus 3, and that gives me negative 4. So my vertex is at hk, which we just found to be 1 and negative 4. All right, so 1, negative 4, it should be symmetrical because parabolas are. And so this thing is going to, in general, look like, that was not very pretty, but there you go. There's my parabola. And it's rounded at the bottom, so it's not a corner. Okay, so there's an example on Desmos if you want to go look at it. All right, solve this one and do the exact same thing. So this is a little different, so you might want to watch me get started here. There's no c term, right? So we've got a equals 1, b equals negative 6, and c equals 0. So there's no constant. So how are you going to factor this? Well, you're just going to factor out the greatest common factor. Factor out an x, and you get x minus 6. So we still have two factors set equal to 0. There's an x, and there's an x minus 6. So we set x equal to 0, and we set x minus 6 equal to 0. Sometimes it's the simple things that throw us, right? So it's 0 and 6. So those are our 2 points. So we've got 0 and 6 on the x-axis. That's where it is going to be crossing the x-axis. All right, so now let's, in order to make a rough sketch, we really need to know the vertex. So the vertex is going to be negative. B is negative 6 over 2 times a is 1 again. And I get 6 over 2 is 3, and the negatives cancel out. So now I need to find my k, which is f of 3. So f of what we just found, negative b over 2a. All right, so f of 3, I'm just going to plug that into my original equation right up there, and I get 3 squared minus 6 times 3. So I get 9 minus 18, which is negative 9. All right, so my point, my vertex, hk, is just 3, negative 9. All right, so 3, negative 9 is way down here, and it looks symmetrical, it should be, and I'm going to have it come down. I'm not very good at drawing down, so we'll try it. Oh, yeah. So we get something like that. Okay, like that-ish. All right, so there's my very rough sketch of a parabola. All right, and again, there's a better one if you go to Desmos, if you're using the OneNote. All right, so let's look at x squared plus 3x equals 0. So we're supposed to solve this. And we're not going to try to graph it, but you can go and look at it on Desmos when you're done. So we get, first we have to factor it, and we get x times x plus 3 equals 0. So our factors are x equals 0 and x plus 3 equals 0. And I don't really need those parentheses, but it might help you to see it like that. So x equals negative 3 and x equals 0. And that is my solution. There's one, there's the other. All right, why don't you try this one? All right, so first you have to factor. So you're going to get x times x plus or minus something times x plus or minus something equals 0. So to get negative 10, I'm going to have a plus and a minus to multiply to get a negative 10. Now I need to think of two things that add, or really the difference because I've got a plus and a minus, to make 3. And I get 5 and 2, and I want it to be positive. So I'm going to say positive 5 plus 5 and minus 2. All right, so I've got x plus 5 equals 0 and x minus 2 equals 0. So x equals negative 5 or x equals 2. And those are my two solutions. And you can graph it, go check on Desmos or whatever, and see that those are the places where it actually crosses the x-axis. So that's how you check your work on these. All right, next one, give that one a try. Okay, so you just need to factor this. So I get x minus and x minus, and I know that because they multiply to make a positive and add to make a negative. So two numbers that multiply to make 24, 12, and 2, and they're both negative, so they add together to be negative 14. All right, so I get x minus 12 equals 0 and x minus 2 equals 0, so x equals 12 or x equals 2. Again, you can go check on a graph and see that they cross the x-axis at 12 and 2. All right, next one. All right, so this one is going to be x plus something and x minus something to multiply to be negative 15. And they need to add together to be negative 2. So that's 5 and 3. It's going to be negative, so the big number needs to be and have the negative in front of it. That's how I think about it. And so we've got x plus 3 equals 0 and x minus 5 equals 0. So x equals negative 3 and x equals 5. And that is our solution. And again, you can check with a graph. All right, that is the last thing I had to tell you about with this. Thanks for watching.